All right, moving on to section 2.4, okay? I believe our test is going to go up to 2.4, so it'd be what? 2.1, 2.3, 2.4, I think. So this will be the last section, but it'll take a day or two, a couple days probably, to go over this section. All right, and it's about, here's a big fancy word, you probably recognize this word, it's about quadratics. Okay, and we'll say quadratic equations because we are going to deal with equations in this. We've actually dealt with quadratics before. We just haven't made them equations. Like when we did factoring, right, with like difference of two squares and all that kind of stuff. That was quadratics. But now we have equations. So we have it set equal to something. So we're actually going to solve for something. We're going to solve for x. We're not just factoring stuff. Remember that? Remember when we did factoring? I said, okay, factor this quadratic or whatever. So we are going to factor, all right, don't get me wrong, but we're going to factor in order to solve for something. So the whole reason we learned how to factor earlier, back, was because we want to actually solve for something, and that's what we're going to be doing right here. All right, so let me just give you the basic formula, I guess, for a quadratic equation. It would look like this: ax squared plus bx plus c. Now right there's a quadratic, but that would be just a what do they call that? Not an equation, but a expression. This would be a quadratic expression. But in order to make an equation, what word basically is an equation? You need an equal sign. That's right. And so what we do is we set it equal to 0. This is your basic everyday quadratic equation. All right. Today we're not going to do this, but maybe in the next day or two, we're going to actually solve for x. We're going to do some stuff and we're going to actually solve for x. It's going to take us a little while to get to that, but we're going to do that and we're going to come up with the quadratic formula. Do you remember the quadratic formula from Algebra 2? Remember, actually, yeah, plus or minus negative b plus or minus square root of b squared minus 4ac over 2a. Do you remember that one? Okay. So we'll get to that, all right? We will get to that. But for right now, we're just going to do this. They call this the standard form of a quadratic equation. All right, so let's talk about solving a quadratic. I'm going to go a little bit out of order. I'm surprised that they go in the order that they do in this book. So I'm going to do something like this. What if I said x squared was equal to, I don't know, 16? Let's start off with that. And we want to solve for x, okay, because these equations, this is an equation, isn't it? Because you got something set equal to something else, and I want to solve. And they'll probably just say solve. Solve for what? Well, solve for x. What would you do here? Plug it in. Plug what in? Plug 16. We're solving for x. We're trying to find what x is equal to. Say it. Okay, square root both sides. Right. Okay, you got to get rid of this squared. So I square root this side, and I square root this side. Why do I do that? Why do I take the square root? That's right. Get x by itself, and it gets rid of this squared. I had one book that said they use the phrase they undo each other. Okay, they're opposites of each other. All right, just like when I had this, when I had like 3x equals I don't know, 10. What'd you do? You said 3 times x. What's the opposite, or what's the inverse operation of multiplication? Is division, isn't it? Okay. Same thing here. What's the inverse operation of squaring something? It's taking the square root. So by doing the inverse or doing the opposite, we say a lot of times, it gets rid of it, right? Cancels out. People say cancel out for everything. But that's basically what it's doing right here. It's canceling out. Same thing here. The square root and the square, they cancel each other out. All right? So x is what? 4. Almost. It is equal to 4. So if I took 4 and I put it in for this, 4 squared is equal to 16. But there's another answer. It's negative 4 also, because if I put a negative 4 and squared it, negative 4 times negative 4 is also positive 16, isn't it? So I actually get 2 answers. I get positive 4, and I also get negative 4. All right, so I actually get 2 answers for this. And we're going to have to start getting used to doing this. There's another streamlined, little easier, quicker way to write this. Instead of writing 2 things like this, yeah, plus or minus 4. So really, that's how we're going to write the answer right there. Okay, plus or minus 4 means it could be positive 4 or it could be negative 4. They're both valid solutions for x. Because again, what was my original equation? It was this. If I put a positive 4 in this, look, positive 4 squared is what? 16. That checks, doesn't it? But I could also put in a what? A negative 4 and do what to it? Square it. What's negative times negative? Positive. 4 squared is 16, and it works as well, doesn't it? So the positive and the negative work. Even after I go over this, I've taught this many times, and then people will say, students will say, after we do this for a long time, well, why do you always put that plus or minus there? All right, this is the very first thing that I taught you, isn't it? Is the plus or minus. That's why. So refer back to this, before you ask a question. Why do you make that plus or minus? Because there's actually two solutions to this. There's not just one solution. There are two solutions. I can put a positive 4 in for this, or I can put a negative 4 in for this. That's my solution. Make sense? All right. I think we've harped on that long enough. Let's do this one. What if we had x squared equals negative 25. Square root both sides, right? So watch. After you get used to this, do you really have to show that square root over here? Now, you know that's going to go away, don't you? But then I have to square root this side. Now, we've talked about this in the last section. What do I do with that negative right there? All right, becomes what? Becomes an I. That's right. A negative inside the square root is like the square root of negative 1, isn't it? Square root of negative 1 is an I. So remember, every time we have a negative in there inside the square root, I pull it out, it just becomes an I. We good with that? Right? We just had a quiz on that yesterday, didn't we? Okay. So now what do you have left? You got the square root of 25, which is what? 5. I'll put a 5 like this. Now we normally wouldn't write it like this, especially if that's a whole number. I wouldn't write it I5. What's the best way to write this? Just 5i. But is it just 5i? You got if you're going to take the square root, it's what? It's plus or minus, right? So put the plus or minus there. All right, because watch, if I were to square this, if I was going to take a positive 5i and then plug it back into what we had and square it, look what I would get. What's 5 times 5? It's 25. What's I squared? It's negative 1, which is what? Negative 25, and that's what's inside of there, isn't it? Okay? Because remember what it was. It was x squared equals negative 25. Agreed? So if I can also make this negative 5i, couldn't I? And square it. See what I'm doing? I'm putting it back into here and see if it's negative 25. So what's negative 5 squared? It's negative times negative is still a positive 25. I squared is still negative 1. Do you see how it comes out exactly the same thing? So that's why we put plus or minus right here. It's very important that you remember both of those because that's your total solution. Now 5i is a possible solution. It is one of the solutions. It's not all of them though, is it? So you got to have all the possible solutions, and that would be the plus 5i and also the negative 5i. That's why it's very important when you take the square root that you put a plus or minus in front of it. We got that? Okay, let's do another. As they used to say, you don't even get that, do you? There was a guy for the Sixers. He was the announcer. Zinkoff. If you go down around where the Spectrum is, they actually have a street called Zinkoff Boulevard. I think it's where they're tearing the Spectrum down now, but it's around there somewhere. I forget the guy's first name, but Zinkoff was the stadium announcer for the Sixers. And so when a guy would he had a real distinct voice, and when somebody would take a foul shot, they would say, "And they'll get another," like that. And so whenever I say we're going to do another problem, and I'll say, "And now we're going to do another." And my friend Keith Wilson, who used to work with me at Newcastle, he's at Elkton Christian now. He's a great, he's a great announcer. He announces games and stuff. He actually, Wilmington University hires him to do their basketball games. He's a great, he could be a professional stadium announcer if he wanted to be. He's that good. Or he could do play-by-play and stuff like that. But he always did that. Years ago, when a guy would take a foul shot, he would bite off his Zinkoff and he'd say, "And he got another," like that. And so it's kind of funny. Anyway, stupid inside jokes. Now you're privy to them. You probably wish you would have never heard that. Now it's on YouTube. All right. Here we go. Let's do this. Again, we're going to solve. All these tell you to solve. All right, look at this. What do you think? What's the first thing we want to do here? Take the square root, right. So now watch. Without doing a big old huge square root here. Let's what's going to happen to this square? It's going to cancel out, okay? And I'm going to have a square root here, but what do I put in front of the square root? A plus or minus. That's right. I'm going to put a plus or minus. See, this number doesn't come out real perfect like the other ones did. Remember, we used 16, came out to a 4. We used 25, came out to a 5. This one doesn't come out to a nice whole number, but we still put the plus or minus out in front. Make sense? So let's see what we have now. Let's clean it up a little bit. Y minus 4 equals plus or minus the square root of 12. One more step and we're basically done. We got a little bit of simplifying to do it. I'll show you in a second. But what's our next step to get y by itself? Add a 4 to both sides. That's right. So if I add a 4 to both sides, now watch where we put this. You could put a plus 4 on the outside. But that's not how they would normally write it. This is how they would normally write it. If you want to be consistent, they put 4 plus or minus and then the square root of 12. But before we do that, let's simplify the square root of 12. We've done that before, haven't we? Let's break down 12. What do you want to break it down into? I would go 3 and 4, or 4 and 3. Right? Because why did I pick 4 and 3 and not 2 and 6? Because I can take the square root of 4 real easy. Okay, so what's the square root of 4? It's 2, what? Square root of 3. So instead of writing plus or minus square root of 12, what am I going to write? 4 plus or minus 2 square root of 3. And that's how we want to write the answer. Okay, that's simplified. Don't keep it square root of 12. Don't put it into a calculator and give me some decimal number. I'll mark it wrong. So when it says to solve, I want exact simplified answers. If you write it as a decimal, that's not an exact answer. That'll be an approximation. I don't want a decimal. I want an exact answer, and I want it simplified. Okay? All right, so that's how you do something like that. What do you think? It's not too hard, is it? Alright, let's see what else I want to do. I think that's it for that part of it. Remember I said they kind of went out of order here. I don't like that first example that they give. Let me go in the problem set here. Find a little bit better of an example. Alright, here's a good one. Remember we talked about factoring earlier. I gave a little speech about you have to remember how to factor and stuff. Well, this is where it comes into play. Let's change colors. Let's go to this blue. Alright, watch this. It says solve. All these say solve. So it starts off x squared minus 5x plus 6 equals 0. This looks very familiar, doesn't it? Doesn't this kind of quadratic look familiar to you? An x squared, an x, and a number. But in the past, the only thing they asked you to do with this was to factor it. But this time, what do they ask you to do? Solve for x. Okay, so what we're going to do is we're going to actually factor this thing. Because, look, if I just move this over to the other side, subtract 6, and then move this x over, it's going to be a pain because I got two x's here, don't I? I got an x squared and I have an x. So what we're going to do is we're going to factor this thing. And I believe this factors real nice, like this. Okay? Remember this? It's kind of backwards FOIL method a lot of students like to say. So I got an x here and an x here. What about my signs? Look, they have to multiply to be positive and they have to add up to be negative. So are they both going to be positive or are they both going to be negative? Both going to be negative. Okay? Now they have to multiply to be 6 and add up to be a negative 5. So 3 and 2. Good. Right? Because negative 3 times negative 2 is positive 6, right? And negative 3 minus 2 or plus negative 2 is the same thing as negative 5. You with me on that? So we're good to go right there. So we factored it. That's stuff that you should already know how to do. All right? I'm just reviewing it. It's been a little while since we've done it, so I'm just reviewing. So where do we go now, though? Let me ask you this. What if I gave you, I don't know, I'm just making up numbers. This number really has nothing to do with this right here, okay? I'm just making a number up. If I said 5 times what equals 0, what would that number have to be, or could it be a variety of numbers, or what? What do you think? 5 times what is going to give you 0? 0. Is there anything else? There's not, is there? So basically, if I said 5 times x equals 0, what does x have to be? X has to be 0. Would you agree with that? Okay, watch this. What if I did this? What if I put two unknown numbers, one x and one y, and I told you if I multiply them together, My answer is 0. So what could I possibly say about x? It could be 0. I don't even care what y is. Y could be any number in the world. But if x was 0, what's this product? It's 0, isn't it? Okay. Or I could say what? I could say y is 0, and x could be any number. Exactly right. So I could either say x is 0 or what? Or y is 0. Agree with that? So let's go back to this. What about this? These two things right here are being multiplied together, and my answer is 0. That's right. So tell me something about this parentheses. Well, if that thing was equal to 0, I wouldn't even care what this number was. 0 times anything is 0. Do you see that? Or I could go the other way. I could call this 0. I could set this thing equal to 0. So if this thing was equal to 0, I don't even care what this was. This could be negative, it could be a decimal, it could be a fraction, it could be a whole number. I don't care. If this is 0, then 0 times this is going to be 0. Make sense? So what I'm going to do is I'm going to set them, either one of these could be equal to 0. So I'm going to set them both equal to 0. So x minus 3 could equal 0, right? Or what else? X minus 2 could equal 0. So let's find out what x actually could be. So if x minus 3 is equal to 0, x could be 3. That's one of my answers. And then over here, add a 2 to both sides, and x could be 2. And that's one of my answers. Would you agree? Because watch, if x was 3, what's 3 minus 3? 0. 3 minus 2 is 1. What's 0 times 1? It's 0. So that's a possible solution, isn't it? Let's put a 2 in for this. If I go 2 minus 3, that's negative 1, isn't it? But if I put a 2 in for this, 2 minus 2 is 0. Negative 1 times 0 is 0. So they both work. Or you could put them into the original problem if you wanted to. Let's do that. Put a 3 into the original one. 3 squared is 9. Minus 5 times 3, which is minus 15. And then what? Plus 6. 9 minus 15 is negative 6. Negative 6 plus 6 is 0. That works, doesn't it? Put a 2 in for this. 2 squared is 4. Minus 5 times 2, which is 10, plus 6. 4 minus 10 is negative 6, plus 6 is 0. That works as well. So they both work. There's 2 solutions for this, not just one. Do you understand why the factoring comes in handy right here? Yeah, because we factor it, right? And then we set both of these factors to 0 because the product is 0. It says right there it's equal to 0. The product is 0. We solve for both the x here. We solve for the x here. We get 2 solutions for that. We good? Okay. Let's do another one like that. Let's do this. I'll do one that's a little bit more complicated with the factoring, but we've done this factoring before. Let me see how I'm going to do this. They complete the square. I don't want to complete the square on this one. Not till tomorrow. Let's just do another one just like we did, just for extra practice. Okay. So watch. X squared minus 4x. Now watch what they do. They change this around just a little bit. They set this equal to 8. It's not equal to 0, is it? But what we're going to do is we want to set it. Remember our original quadratic equation? Yeah. Oops. See that right there? I want it to start off like this. I want the x squared, then the x, then the constant, and I want it set equal to 0. So Ryan, what'd you say? Exactly right. Yeah, because I want this equal to 0, so I'm going to stick this 8 on the left-hand side. Right. So that's what I want to do. Okay, so I first want to start it off so it's in the correct order. It's in my standard form, right? The standard form of the quadratic equation. Now I can go ahead and see if this thing will factor. So let's see if it factors. Now not all of these are going to factor. We're going to learn a little method maybe tomorrow, I think, in case this didn't factor. But I think this one does factor. So look, x and x, they multiply to be negative, so that means one has to be positive and the other has to be negative, correct? Actually, this doesn't work, does it? Ah, yeah. Yeah, there's nothing, because what do I got? I got 8 times 1, I can't get this. I got 2 and 4, and I can't get a negative 4 out of that, can I? So this doesn't work, does it? So what do? we wait till tomorrow, okay, to do this problem, because I'll show you a way to do this tomorrow, right? But I thought I saw these numbers and I thought it factored until I actually set it up like this. But you're right, this does not factor. I didn't do this on purpose, but this is a good point though, because this is what we're going to do tomorrow. So we'll maybe even write that down tomorrow. Yeah, that's completing the square. Let me they really don't give you. Okay, here's a good one. Let's do this one. So 6x squared plus 7x minus 3, and set that equal to 0. And let's solve for x. Okay? Remember doing this kind of thing? You got a coefficient out in front here. It makes it a little bit more difficult. I don't know. Remember there was a way to do it. 6 times negative 3 is negative 18. Do you remember that? And then you split it up into 4 things and you do the grouping. I don't know if you remember that or not. But remember I showed you kind of a special way to do it. I don't know. Or we could do it by trial and error, right? So let's just do it by trial and error. Let me get out of here. 12:20. Okay, I got 5 minutes. So what do you got? You got 6 and 1 or what? 3 and 2. Let's just try 3 and 2. And I haven't even looked to see how to factor this yet. Okay, I'm just trying some stuff. We'll see. Maybe I'll get lucky, get in on the first shot. Maybe I'll have to try a couple other things. What about this? Negative 3. That means one has to be positive and one has to be negative, right? Or it could be the other way around. I might have to try it again. 3 is just what? 3 and 1. So how do we know if that works or not, if that thing's factored? Well, that's not really going to tell us if this factors or not. But what do? We do the FOIL method, right, to see if this is going to come out to a 7x. So I know my first one is 6x squared. I know my last is negative 3. It's the outside and inside I have to check. So let's check the outside. The outside, if I multiply those together, would be what? Negative 3. The inside would be positive 6. Does that give me a positive 7? No, it doesn't. So I'm going to have to try something else. Let's just try switching this around. Let's make that negative and make that positive. Let's just see if that works. Outside is positive 3. Inside is negative 6. That still doesn't work, does it? Okay. Let's switch the 3 and the 1 around. So let's make that 1 and make that 3. Let's see if that works. 3 times 3 is 9, and then this is minus 2. 9 minus 2 is positive 7. Yep, that works. Had to try a couple things, didn't I? Right? It wasn't that hard to just flip things around, switch things around a little bit, and that's it. Is that my answer, though? Does it say just factor it? No. What do you think this says? It says to solve. So we got to solve. Now look, I got two things that are being multiplied together, and they equal 0. So what do I do with those two things that are being multiplied together? Set them both equal to 0. Exactly right. So 3x minus 1 equals 0. And then what else? 2x plus 3 equals 0. And now we just solve for x, and we'll be finished. You can do this in your head, can't you? Add a 1 and then do what? Divide by 3. So what is it? It's 1/3, right? What about this one? Subtract a 3, right? And then divide by 2. There's your answers right there. They don't always have to come out to nice, pretty numbers. We're not going to do this, but if you wanted to, you could take that 1/3, okay, throw it back into this, square it, multiply it by 6, multiply it by this, add them all up, and they should all come out to 0. Put in a negative 3/2 for this and this. Plug it back in. Work it all out. See what it comes out to, and it should come out to 0. And it will. And that's the kind of stuff that we're going to do. Now, notice, this did factor, didn't it? All right? It did work. It doesn't always work. Remember? This one right here didn't factor. So we need another way to do it. And that's what we're going to do tomorrow. So the problems that I'm giving you today, all the ones that look like a quadratic like this, they will factor. All right, so keep trying. They should all factor, and then just solve for x. So those are the different types of problems that you're going to be doing on the worksheet today. Everybody got that? Yep, I don't think there's any surprises on this at all. All right, that's it.